your life is about to change. Or maybe not, but it's still going to be fun. Worst case, I'll be humiliated because I don't know what I'm talking about. Nobody knows what Docker is and how it works. We're all guessing. We're all hacking our way through. It's kind of like a job interview. You don't know anything. You pretend you know, and then you learn after you join the company what the hell you're supposed to be doing. Who am I? My name is Oren. I live in Los Angeles. I came here only for a few days. I'm pretty excited. I've been to Toronto, but I've never stayed here for long. So that's my first time. So that's my GitHub and my Twitter, Oren G. Feel free to tweet or do whatever you want. I work for Sanguine Bio in Los Angeles. It's a medical startup, and we're accelerating and enhancing medical research. So we're taking the Uber approach, where we're applying it on clinical research. So if you're Pfizer, one of our clients, and you're to cure breast cancer or something like this, it's going to cost you $1 billion in 10 years. So we're helping you to shorten the amount of time and the money, which is important. And the Uber approach here is that we're sending our phlebotomists and nurses to people's houses. So if you're sick and you're part of a medical or clinical research, the last thing you want to do is go to the hospital. So we're sending the doctors to your house, taking whatever needs to be taken, and sending it to the researchers. And we're hiring. So if you're willing to relocate and come to LA, it's a little more sunny than Toronto. Not necessarily better. I actually like cold weather, but if that's your thing, let me know. I prepared a bunch of swags. Bunch of companies, and also my company, Sanguine, donated a few of them. It's pretty cool. And the best one is socks. That's amazing, right? Like, what the hell? So yeah, I'm wearing it as well. It's super comfortable. I'm not. It's black. So, and I don't know if you guys are watching Rick and Morty. Do you have Rick and Morty in Canada? Yes. Yes! Awesome. So there's no Rick and Morty jokes. Only like 2 slides with them or 3. I just like it. It's the best TV show, except for a few others. But yeah. So that's me yesterday with a few of the other speakers. We had fun, as you can see. Everything that I'm talking about is available, and I'm kind of like dogfooding the whole thing, so you can actually use Docker to grab the slides and run it. So basically, it's a website that's running on Nginx, my entire slide. So if you go to Docker-culture at Sanguine Bio, you can see it. And you can run it locally. You need to install Docker. But after you install Docker, within one line, you have this Nginx running locally. And this is the second command, which is pretty cool. The -p is for the port. So you can decide the first number is what port you want to open on your laptop. The last one, the second number, ignore it. It's just internal for the Docker itself. But you can change it if you don't want to run on port 80. Then you go to the browser, localhost, and you have this presentation running. And the repository is here. I'm going to update it a little bit. But that's everything is there. So you don't need to take notes unless you want to, or you can draw pictures of cats or whatever. Please leave me feedback. So the reason why I want feedback is because I have a very thick skin. The best way to get thick skin is to go to an AngularJS meetup and tell them that Angular is dead. So that was the name of my talk. Angular is dead. I gave it almost a year ago. It was like 9 p.m. People are tired, but they were passionate. They threw sticks at me. And it was recorded with my crappy camera, crappy audio. So I was ashamed of the whole dynamic in the room. It was like hostile. Even though after I told them that it's fine, it's not dead, but I think that people should like open their eyes, And it's tough. It's like we're monkeys, You get a banana, and it was a research that showed that if you get give monkey a banana, you're going to show him another banana which is bigger. He will stick to what he knows, right? I'm not saying that Angular guys are. Anyway, it's a natural tendency to after you invested energy and time in something, like you're not going to let go. So yeah, I have a thick skin because I put the video on YouTube, and if you Google for Angular is dead, 5th result, the first video is mine. And I didn't publish it, didn't blog, didn't tweet about it. I was kind of hiding it. And then a few weeks ago, one of my teammates, and hey, Oren, I noticed you have 18,000 views on Angular is dead. I'm like, no way. And then they told me, the team, hey, enable comments. It's going to be fun. So that's why I have thick skin. I was called dipshit after I think 3 seconds after it was enabled comments, boom. So So yeah, use the website, the beautiful TELUS website, and leave some comments and tell me if you think I'm a dipshit or maybe not. Where is it? If I scroll down, somewhere here, right? Yeah. So that's the agenda. We have, I have no idea what the time is. Whatever, we have some time. And so I want to talk a little bit about kind of like the where Docker fits in kind of like a little higher level about software methodologies, and one of them is Lean and how it fits. Docker is not the only thing that I want to talk about. So that's why I mentioned graph databases. I'm very passionate about graph databases, and I think it's a better way to model the world as opposed to relational databases, and I'll tell you why. The only thing is the tooling are not exactly there yet, but it's getting there, and I want you guys to, take a look and play with some stuff that is coming. And the last one is, I think, the evolution of Docker and containers, which might be a function. So if you ever heard about AWS Lambda, you just write your function and just throw it above the AWS wall, and it just works. So you don't care about servers and EC2s and ELBs, a load balancer. It's just a function. So I think that's where we're heading. Still Docker behind the scene. It pops up a container for you within a millisecond, and it's running. So you need to know about Docker, but I think eventually the people who will care about it, the people who are building the platform as a service and the infrastructure guys, it will be plumbing that we won't care. So I think it will be nice. Hopefully we'll have time. And yeah. If not, we can always talk about it later. And yeah. So yeah. So those are two books that I really like. The first one is the book that I read when I first moved to the US. I apologize if I'm loud. It's kind of like a privilege to move to America. It can be loud. So I read those two books and about lean and lean manufacturing. So the idea basically that I want to share with you is it came from manufacturing, and now the software adopted lean. There's a few principles, but what we care about for this talk is that you need to identify waste in your process. And everything in your company consists of multiple processes. The engineering is a process to do the input and output. And the input can be an idea, and the output can be actually something that is enlightening your customer, right? And also onboarding an employee is a process, right? So you need to find what is the process and what is the item that goes through the process. And there's techniques to visualize the process, because if it's not visualized, how do you know where's the bottleneck? So that's kind of the idea. So I can't summarize in 10 seconds, but that's those books are about. And this is a quote from Peter Drucker, which is the guy who kind of the father of management. He's not alive anymore, but I think in the 70s or 60s, he talked about culture and strategy. And I think that it doesn't matter how much your strategy is great and how your processes are great. If you don't build a good culture, nothing really going to work for you. And it's kind of related to the previous talk by Ahmad that talked before me. He mentioned the open source movement, how you can apply open source methodology on the way to build software. So yeah, I would recommend you guys watch the video of his talk. Pretty good. That's an interesting study about the time it takes to deliver something. If you have something that you can't do it yourself within the team, it will take you way, way longer than if you can finish everything within the team. Okay, and it kind of makes sense, but it's also validated in studies. And I'll show you how it's related to Docker. So everything you make, every decision you make, every technical decision, and sometimes non-technical decision, will have an impact on the velocity of the team, right? How you structure your team. Do you have a QA as a separate kind of like a piece of the organization, or do you have the QA embedded, right? That's what Scrum is talking about with cross-functional teams, right? What about security? Do you bake in security within the process, or do you have external security team that's doing auditing after you guys start development? And you can see different examples like Google versus IBM in terms of like how they manage their R&D. And at Google, they're trying to put the R&D team together with the engineers. So it won't be like an ivory tower that somebody think about, a crazy algorithm and then just drop it with a crazy language that the engineers need to translate into whatever, Python or Java in Google's case. So they embed engineering or R&D with engineering, which I don't know if IBM is doing it, but I know in the past it was very separate in some companies. So that's the team structure. Actually, I have a few slides about this stuff. So I don't know if you've seen this one. But you have this product very separate, and you poop something, and you need to like deal with it and tell them that you can't do it because it's too much and it's crazy and whatever. And you can apply it. I just changed it, right? Like you're doing something, you don't care about the testing, and then like, hey, wait, what about those cases and how? So, and I think that's oh, I have an R&D in dev. So I just changed the so the same with programming language, like, you can use Node.js now, and then in theory, you can have the same guy writing the code for the client and the server. Maybe, maybe not, but it's a decision that will affect your velocity, right? Data stores, which I hope I'll have time to talk about, which is how do you model your data? What's a good way to do it? And how to minimize the friction between the real world and your code, which hopefully graphs help solve. And the DevOps movement as well. The idea of DevOps is to have people who normally are separated, but bring them now as part of the team. Many teams just don't have DevOps. They have engineers that are very mindful about deploying stuff. UI, anybody heard about React? Obviously, yeah. So what's interesting about React is that they took, at Facebook, instead of like layering everything by the technology, so having one file over there in some folder for the UI, for the CSS, and another file for the logic and some data fetching, they put everything together in one file or one folder. So it has high cohesive, right? So there's two aspects in software, cohesive and decoupling. So if you have high cohesive and low decoupling, that's a good sign. So that's what they did. It's high cohesive. Everything you need is inside a component, right? Even the data fetching with the GraphQL and Relay, which is a new open source component that they announced recently. You can have the entire thing, even the CSS, written inside a file. And it's decoupled because each component is not connected to another component. So the decoupling is not between the architectural layers. It's between your components. So I think that's why this is shift, and that's why I gave this talk a while ago about Angular is dead. Because Angular learning from React now and embed a bunch of things from React. So all those, even Ember, they're all kind of converging, all those frameworks, into something that looks similar. Oh, I didn't mention something. You guys are very quiet because you're thinking that you need to wait. So my style is like, don't wait and just harass me with questions. If it will be out of control, I just tell you not to. So any questions so far? Concerns? No. OK. Let's move on. So now we're in the Docker part, which is the kind of like the biggest part in the talk. I'm trying to tell you, to show you what does Docker solve. And after we understand the pain, I'll dive into what Docker is. And then I'll talk about two aspects. One is applying Docker on your development environment as you as a developer. And the last one is actually show you a few approaches for putting Docker in production, which means how to orchestrate between Dockers and if you have it on multiple hosts, and how to achieve zero deployment and redundancy and so on. And I'll tell you the basics of how to do it yourself if one day you want to, and also a few tools that are already doing it for you. It's workflow tools, so you don't need to actually do it yourself. You can just use them. And I'll try to demo some of them. Strangler. So that's an interesting. If you look for, it's a crazy tree. It's a what type of tree is it? I can't remember. It grows in like Australia or something. And the way it works, it grows around the host tree, around it, and eventually destroy the host tree. All is left is the parasite is left basically, and the original tree is being destroyed. And it's a kind of technique that I think Martin Fowler mentioned as a way to redesign or refactor a big code base. If you're trying to move away from PHP to Node or from whatever one language to another or technology, it's hard to do it in one time. So what you do is you start with the nodes. You create maybe microservices that replacing the nodes of your app, and slowly it eats the entire host tree, which is your legacy code. So it's a technique to remove legacy code and switch away from it. So that's kind of like how Docker is kind of related to this stuff, because with Docker you can easily create, or easier way to create microservices. With microservices, you can take this approach and slowly extract functionality from your legacy code, and eventually you're going to stay with the new code, which is the microservice approach. I have a video of this tree grow, but just Google for it. It's awesome. Conway Law, I'm sure that you heard about it. If anybody went to any DevOps talk. But this guy, Conway, he said that the way that your code looks like, the architecture, is actually a reflection of your social group, social gathering in the office. And this is this fun little examples, not really for the exact law, but it's just interesting. You see guns in Microsoft, and Oracle has legacy system, which is big, and Apple is centralized. Just interesting to see it. In my specific case, I joined the startup I work for, and I asked the engineers, the team, hey, can you draw me everything? Because they haven't done it. I want to know what's going on. What are the components? Who's against who here? Like, who calls who? And I noticed something interesting. What's going on there on the bottom left corner? Like, who did this? I totally isolated, right? It's like its own little thing. And like, oh yeah, this guy, consultant, he came for 3 months. It didn't work out. You know, after 3 months of stuff, we just realized, basically, he worked in isolation for 3 months. And it's reflected in the architecture. We used Salesforce in the past. We're migrating away from Salesforce, but back then, he used it directly without our API. He just built his own little world. And then after 3 months, boom, it just pops up. I'm done. Anybody knows who this dog is? Dude, you rock. Here, suck. So yeah, I don't know the name of the dog. Anybody know the name? Which one do you want? Do you want a stock, or do you want to? You know what HIPAA is? Keep it HIPAA. You should keep it HIPAA. Trust me. It's something that people in the medical industry knows very, very well. Basically, you have to a lot of regulation that you have to follow if you want to build a medical-related product. And then there's something called inverse Conway maneuver. And if you follow, there's something, ThoughtWorks. It's a pretty cool company. They're consultancy, and they have every year like a ThoughtWorks radar, which is a website where they publish all the recent things in the industry, and they divide it by tools and technology and languages. And they mentioned the inverse Conway maneuver, which is, if you know about Conway Law, let's create a social structure that will have a great architecture. That's a tricky part. Or maybe, I don't know if that's what they meant, but maybe the other way around. Try to build architecture that will force you to be in separate structure. I think it's the first way, but take whatever you want from it. So yeah, microservices, you've probably heard about before. There's benefits and there's challenges. I'm not going to talk about it too much, but it's related because Docker makes it a little easier to build them. This guy works for Amazon. And I think he was hired by Steve. He's like an ex-ranger. He's like super crazy guy. And he will not let you access a database of a different service unless it goes through the API of the service. And if you will, he will punch you with a dead fish, and he will break the table. I'm kidding about the breaking the table and the fish. But he will scream at you and try to get you fired. No kidding. Anybody knows what is this made of? Amazon. What do they use for their tables? Who said door? You want a stock or do you want a lip? Dude, there's only one stock. One for myself. Oh, just pass it on. So they use door, and it's pretty cool. It's like they're super lean in the way that they running their operation. And I think it's pretty interesting. And what he said, that kind of reflects, I believe in this stuff. He tells the engineers at Amazon are different than Google. At Google, they have a team, SRE, I think. Like the people that you just throw your stuff at them, and they're going to make sure that everything is running. They're going to get phone calls in the middle of the night. And Amazon, the team itself, are taking care of it. So that's what he says. If you build it, you're going to run it. It's pretty cool, but can be tough if you're not used to it. And you need to have the right skill set. So it's also culture change. You need somebody that instead of being the security guy or the DevOps guy, it needs to be more of a mentorship kind of a thing to assimilate the knowledge so the team itself can do it. And there's another problem that some people just don't want to. I don't give a F. I just want to write the UI or whatever. So if you have this case, then you just can't do it. So you can't just go back and say, I want to apply this stuff. You got to look at your team and look at the social aspect and psychology, if they want to do it. I didn't really talk about what they're trying to solve, but I guess I would say that it helps with the microservices approach. And it helps to the way Docker works is that the same thing that you're running on your laptop is going to run on production, which is pretty cool. Have very, very safety kind of feeling that things are going to not break, hopefully. That's the biggest thing in terms of having more stable environment. So now I'm going to just dive into Docker itself. A little bit of the background. Basically, the way it started is the companies like Heroku and Amazon, companies that managing servers for us, they wanted to save money. And they wanted to utilize the servers as much as they can. And previously, they used virtualization, but and you'll see in a few future slides, virtualization is not the most efficient way, and containers makes it a little more efficient, save them money. That's how they started, and the company called .cloud, actually, now it's Docker, they built the API that basically Docker was existed before in Linux machines or Solaris, but they took it and built a nice API on top of it that we can consume without being like super hardcore engineers. And then they changed the name to Docker. And now people are using it, and it's open source, and so on. So if you don't know what chroot, you want to understand the first line. If you do, so it's kind of like chroot, but with some additional stuff. Basically, it's a way to isolate a process. That's it. And if you think about the Walmart metaphor, somebody on the chat room told me this. I think it's pretty cool. Think about Walmart, and there's a guy who has like the vegetable aisle. And if you're going to ask him, where is he work? He's going to tell you, I'm in a vegetable store. He doesn't even know, right? Think about it, he doesn't even know that he works in Walmart, right? He's using the payment system that Walmart are using, but he doesn't know it. If you're going to ask him what he is, he's just selling vegetables. So that's kind of a Docker. If you're inside a Docker, he doesn't know that there's like a host system underneath. He thinks that that's the operating system. He's using the kernel of the host. So if you're running 100 of Docker containers on your machine or maybe on production, it's actually using the same kernel as the host. And that's why it's more efficient than virtualization. In virtualization, you have like the entire OS, including the kernel, because the OS has a distribution, which is the packages, and the kernel. That's kind of a consistent OS. So it's using the kernel, basically, of the host. And that's just kind of like what I just mentioned, that you can see that all the containers, the 3 containers on the left, are using the kernel. And it's more efficient in terms of I/O. There's less overhead than VMs. And you can see on the left how VM works with the hypervisor. It's basically the entire OS. You have multiple OSs, entire thing, including the kernel, as opposed to Docker, which is just using it. And that's kind of what I kind of mentioned, the value. I think it's pretty cool, even for non-technical people, like people who are product. And I'm going to show you some stuff that I'm playing with, and our product guys can use as well. Like, I want to find like a new wiki for our company. Like, how do I do it? I'm going to different places. I'm just running Docker command if they support Docker. And within one line, I can just experiment different products without cluttering my machine with Java and whatever dependencies or. So it's not just for engineers. I think it's going to be valuable for other people as well. It's kind of geeky, so product people are scared of it probably, but that's our job to make it easier to consume. So yeah, that's the dev. OK, so I'm going to just skip this bunch of commands. But the main command we're going to use is Docker push to push stuff from the Docker hub. So Docker hub looks like this. It's basically a repository, kind of like GitHub, but for Docker. So you can do Docker push your Docker, and you can name it with the namespace. My name is Oren, or yeah. And I can see all my containers. And you can see here automated build. So for this talk, it's actually hosted on Docker Hub. Every time I push to master, it automatically being pushed to the Docker Hub. And you can use also webhooks. So you can send a webhook after it was built, and you have the image. I didn't even explain to you what an image is. But the way you build Docker is you first run the build command. The build command looks at a file called the Docker file. In the Docker file, you define your Docker. You say, hey, this is Ubuntu, and it has Ruby on it, and it needs to run some commands. So build, turn the Docker file into an image. And you can think about an image as like a zip, like a bundle of stuff, of files. And then you run another command called docker run to take this image into a running container. So you think about the image as a blueprint of thing that you can instantiate, kind of like a class and object, maybe in Java. You can instantiate, based on the image, a running container. So Docker Hub hosts images for you. So when you run Docker push to the repository, it's going to be there as an image. And then with the hooks, you can actually go and maybe call your CI to maybe go and do Docker pull on your production boxes to pull from the repository. And then Docker restart. Yes? Can you host your Docker Hub? Yes, you can. And it's one command. It's literally Docker run. And I can look it up, like Docker repository. It's like by Docker. They have like an official. We can actually look at. Let's show you how to do a search. So the question was, can I host it myself? And the answer is yes. Let's do Docker Hub, maybe. And you can see here, I want to take this guy because it has a lot of pools or a lot of like stars or whatever. I don't know what this is, but you can try it. Basically, if you do Docker pull this, and then you need to do Docker run. Basically, a command or two that, I don't know if that's the one, but you can literally fairly easy do it. You need to maintain it yourself and have like enough space and everything, but yeah. So that's the Docker Hub. And yeah, that's the build command. And you can give it the -t for the name that you want to call it. And dot is like, where is the Docker file? This file that creates the image. And then Docker run. And you can give it a name. Yeah, the name is the name of the container. And the last one is the image name. So you got to match the image on the top. And there's a bunch of commands that you can do Docker PS to see the processes, what Dockers are running, or Docker images, what images you have in your system. Let's ignore this slide, it's annoying. So let's talk a little bit about the development flow, right? I'm going to show you a few examples. So when I first joined the company, I noticed that there's a ton of dependencies. It took me a week to set it up, and I was pissed. So what I did is I created a few containers for everything I need. So all the green things are containers. So we have proxy, which is Nginx. And then we had like an app that is split into two pieces. So some of it went to the PHP, depending on the route, the URL. And some of it went to Node.js. So I put anything in a container. And then I also created the log container. So there's somebody wrote this Docker container that you can use to grab all the std out for all your containers and send them to, it's called the system rsyslog, which is a Unixy kind of like tool for logging. So you can send it to even external place. So you can then send it to your log server. And on the log server, you can go and try different, I tried the Heka, which is a project written by Mozilla in Go. Heka can accept both statd. Statd is like an application level, like login count, increment count 1, for example. That's application logging. And it also can accept a regular log from rsyslog. And then Heka, and you can move it to Elasticsearch and Grafana for visualization. So that's what I kind of like started doing, but we're not running this product anymore, so I can't even demo it. Also, databases. You can also Dockerize databases fairly easy. The tricky part is Docker is not maintaining any state. So it's stateless. So after Docker is shut down, you turn it off, then what happened to your data? So the way to deal with it, there's a few ways. One is like called the Docker volume. You can look it up. Another one is using the -v in the run command. -v will mount your file, the local file, to the file inside, or a folder inside the container. So you can do -v, let's say /data, which is going to be /data on whatever host on your laptop, will be mapped to /data inside the container, or wherever the database is storing the files. And therefore, that's how you basically, even after the Docker is shut down, it will still be saved in your file system. So, but the truth is that not many people are using it for production. Not many people Dockerizing. So for me, I'm Dockerizing everything I can. Even the DevOps tool for myself to deploy stuff, I need to like the AWS CLI. I'm using Amazon, and I'm using if you're using Chef or Puppet, or if I'm using Ansible, I'm still Dockerizing this stuff. And then somebody can go do Docker pull of my deploy tool, and we'll have everything. You need to pass the keys maybe for Amazon or whatever, but you have everything contained. So even the tool that I'm using, I'm Dockerizing. So I use Docker as a kind of a glorified bash wrapper, basically. And then nobody needs to install Python and Boto or whatever you need to install, and maybe Ruby, depending on how you deploy Capistrano. All you need to do is have Docker installed on your machine, and then run your deployment container. Other examples is, Docker Cordova is a repo that I created for Cordova and Android development. I don't want to install Java, right? And you live only once, and I'm tired of installing the same stuff all over again. So I created this guy, and you can look at my repo. And I do an example of how to run this stuff. But basically what it's doing is it bundles. I copy for somebody else and modify it because I need to have the mapping of the USB need to work as well. So when I'm connecting my Android phone, it needs to understand that to connect to the container. But that's about it. And it kind of works. I think it's still working. I'm not doing a lot of Cordova right now, so I'm not sure. I'm getting pull requests once in a while, and I'm giving people like permissions to update the stuff and be moderators and collaborators. I just don't have time, but yeah. So you can run it even for Android. Another example, so research, our research website. Let's see if I can show you the site. Research. So that's our new site for the research part. And it's using a bunch of technologies that I'm not very familiar with right now. I mean, I used to be a Ruby guy, but using Sass and Ruby, and you need Compass, a bunch of Ruby gems, and it's kind of like annoying to set it up for development, but also for me to push to production. It's annoying to install everything. So I just Dockerize everything. I'm not going to show you how a Docker file looks like. So that's a Docker file. Oops, font, huh? Too small. Let me, there's a new feature with Linux. Making file of myself. Thanks for the guy who helped me with the Wi-Fi. It works, it took half an hour. Linux is gonna take over the world probably 2016. We'll have to wait one more year. It's like 30 years that every year people are saying it. Can you see the screen? Kind of? Is this better? Okay. So yeah, so from. I'm using the first time from line. There's only a few keywords that you need to learn. You can also see the reference on the Docker website. But from is like, what OS do you want? You want the OS inside the container to be Ubuntu? Do you want, it's only Linux, unfortunately. This one is Alpine. Alpine Linux is a tiny little Linux distro. It's only 6 megabytes. 6. So it's pretty awesome. So I'm using it for everything I can. And then I can it comes with a little package manager called APK. So you can do APK add. And you can add Nginx and PHP and whatever you want. That's what I'm doing here. So I'm adding Ruby, right? And then I'm removing it because I want my container to be small. So I think this one is ending up like 30 meg, which is pretty good, right? As opposed to Ubuntu. Ubuntu would be like 600 meg. And then I'm installing all the gem I want. So the run command that you see here is everything that you see here running inside the container. So when you're going to do so the build command will take this file, turn it into an image. And in this image, we'll have everything that you specify here, right? Copy is important too, so I'm copying all my files. So copy lets you copy stuff from your local machine into the container, right? In your production environment, you don't want to run git pull, clone your repo. I mean, you can, but it's nice to have like a Docker container that has everything, the image, that have everything inside, except for the secrets. The secrets are usually separate, and you bundle them together when you deploy. And which is part of look it up, it's called 12-factor app. It's from Heroku. It's kind of like a way to build apps. So it's very, very short, like how to do the logging and how to do the configuration. And this is a big chunk of the big part, which is the configuration should be separated from your app. It's a better way to manage stuff. You don't want secrets to be inside. So you copy stuff that you want to copy. And then here I'm copying everything. So the dot, I'm copying the entire website into the src folder. And then what port you want to expose. That's basically it. There's another file called Docker Compose. So this file lets you put multiple containers. So let's say you have a database and you have a bunch of services. You can put them all in this file. So let's say I have my database. I can call it MyDB, right? And let's say the build can be MySQL. If you see this stuff, MySQL, to actually go to the Docker Hub to grab it. Because notice that there's no, I can do this, let's say Oren. So if I have a MySQL on my Docker Hub, it will grab it from mine. But if you don't specify a namespace, this part left, it will just grab the official MySQL, which probably exists. So I can literally, it's recommended to use Docker files, even though you don't have to. You can just grab it from right there from the Docker file. But that's the official MySQL. There's some instruction of how to run it. So basically, Docker run, you give it a name. Look at the -e, that's how you pass environment variables, with your password and whatever. And there's a bunch of examples. Yeah. So that's the Docker Compose that you compose multiple containers. In this case, I'm only having one service called up. And that's the ports that I defined. Notice it's duplicated. I already had ports over here. So you don't have to do both. You can remove this if you want and only put it here. And this is the volumes at the -v. So Docker Compose, what lets you do is, instead of like remembering all the arguments, you can just put everything in here. So without Docker Compose, you had to do Docker run, -v, and then -p for ports. But you can define them in this file, so it's convenient. It was a separate project called Fig, and Docker decided to absorb Fig into Docker, and they call it Docker Compose. And that's the command you run, basically. So when the Docker run, when you run the container, you got to specify the command to run. So I'm running bin run. Let's see what's inside. I don't remember. running Nginx and running PHP and Compass to watch the files. Let's just try it and see what happens. So I have DC is Docker Compose. It's an alias I have. You can do Docker Compose if you want. You can see all the commands, right? Let's do up. Up will build and will run. And it was very quick because I already built it. So it's cached already in my hard drive. So it was super quick, and that's it. If I go to localhost, I need to change my alias file. 1 second, sorry about this. I need to define here laptop. So basically, inside my Nginx, I specify that I wanted to go access laptop-research. So I have to change my entry in my etc host file. And that's it. So laptop research, and I'm done doing some stuff. I'm done with this. I'm ready to put it in production. All I need on my production box is to have Docker installed and run the same command, Docker up. Docker restart for restarting it, and that's how I can actually deploy with Docker, basically. Does it make sense, or I was too fast? Oh, yeah. The way it works, basically, if you will, you can go inside the container and to see all the. It's using environment variables. So I want to show you how to go if you want to troubleshoot your container. So we have a running container here, right? Let's try to troubleshoot it. Let me open this in a full screen somewhere. Let's do a little Linux fanciness here. So Docker PS. Docker PS will show you all the containers that are running, and you can see that I run the bin command, and the image is research up, and you can see the ports that are open, which is 80 and 443, right? And you can also do Docker Compose PS, which show you very, very similar. And you can get inside, so you can do something like Docker exec it, and then you do the name of the image, the container. And then you can run commands, ls. So this ls is actually running inside the container. And if I want a proof, I'll do pwd. And you see, I'm asking to show pwd, show you the location, the path. And it show me /src, because I'm inside the container. The command was running. So exe exec lets you run a command inside the container. And I can run sh. What sh will do, it will put me inside. So you see here, I see pound here, that I'm inside. I'm inside my container, and I can do, let's see what is running. Now you can see that the PHP is running, Nginx is running, right? All the stuff that I stuffed in during the Docker file, when I do the Docker, I never run Docker build because Docker up is doing build for me. But that's where what happened. It installed everything, and see Compass is running as well. So back to your question, if I do env, it would show me all the environment variables, and all the secrets would be as an env. That's what the -e is doing to when you saw the MySQL. So I have other examples about how the wiki is running. I just try to find a good wiki. I found DokuWiki, which is PHP, and I don't want to deal with PHP. No offense for PHP guys. I never done PHP. So I put everything in a container. So I found a container, it modified it. Same with another wiki that I found called Golan, which is pretty awesome. It's using Markdown. It's using GitHub as the database. And you can try it yourself. And I think I have videos. Yeah, I recorded some videos because I don't trust the demo god to actually let me do the demos with Wi-Fi and everything. So I have recordings, and it's all, you can look at it later. So let's talk about the production a little bit. So what do you need to have running Docker in production, right? What do you need to think of? So there's 3 main components, scheduler, discovery, and registration. In a scheduler is some component that needs to look at your cluster of machines and decide where to put this new container. Host 1, 2, or 3, based on whatever. It can be round robin, it can be looking at the CPU or memory, whatever threshold so depending on the scheduler, depending how sophisticated it is. So there's already an example for existing schedulers that you can use, and I'll talk about it a little bit later. But that's the idea of scheduling, right? So you need some component that decide where to put your stuff. And discovery service is basically if an app want to use a service, how does the app know where to go, right? What is the IP and port? So every service that is being created, let's say you have like a new whatever API that you auth your auth service, authentication. All the other processes needs to know how to access this auth. So that's the discovery. The discovery looks and it put the kind of like the address of where to go. So one of them of the discovery services, it's called Consul. You can run it with Docker. You can just do Docker, just look up Consul in the Docker Hub. And you can see here, I'm running it on one of my machines, and it just shows you all the running containers that are running on this specific node 1. And every time the container is running, this Consul knows about it and publish it to this Consul API. So you get an endpoint that you can query to see what services are running on where. This is just one example for this piece. And this is like a high-level overview of the entire ecosystem. So if you start from the bottom, that's like what we talked about is the Docker engine that we I demonstrate, right? There's something called Rocket, which is I'm not sure exactly what it is. It's a newer thing that competes with Docker. Then there's discovery tools and etcd, a Consul, and the older one is Zookeeper. Those are tools that help you to do the discovery piece. Schedulers, that's the first component that I talked about. So Fleet Marathon, Docker Swarm is something from Docker. The rest are not from Docker. So Mesos, Marathon, and Fleet are external companies and built. But it's the same idea. It's scheduler. And the top one is workflow tool, which may be relevant to you guys. Like, if you don't care about actually doing it yourself and finding the right pieces and assembling them together, just use a workflow tool that will take care of it for you. And I'm gonna, if I have time, I'll demo 2 of them, Dace and Convox. Otto, I don't know how to pronounce this, OTTO. That's from HashiCorp, the company behind Vagrant. So it's a pretty good company. People trust them. So they built something on top of Vagrant. So we can kind of like have a VM and inside containers for your development and then later on for production. Never used it, so I don't know how good it is. And Kubernetes is more like, I think it's from Google. It's more, for if you have hundreds and thousands of machines, you probably want to think about something like Kubernetes. If your workload is smaller, I would stay away, but it's just me. So that's Dace. Speaking of Dace, I need to find a good question about Dace. So you're going to get the last sock. Dace was, I used Dace a little bit a few months ago, and recently they got acquired by EngineYard. And the lead of Dace, Gabriel, actually is the CTO now of EngineYard. It just shows you like where EngineYard is going. They're betting on the Docker, I think. So Dace is a pretty cool product. Within, it took me a few hours actually, but maybe now it's easier. You can set up Dace on any platform you want. You can set it on your own servers, on Amazon, DigitalOcean. So it's kind of like platform agnostic, which is pretty cool. And it has all this components that I mentioned, the scheduler and the registration and everything. It's all already working. And it's actually internally using 10 Docker containers. So it's pretty cool, the Dace itself. And basically, you have a command line, CLI, which I'm showing it. Let's ignore the diagram. It's pretty cool, but you can look at it later on their website. Even the logging, the monitoring. So let's say you have a service running on 5 instances running on your cluster. It's the same app. When you want to see the log in one place, you just do Dace logs and the app name. You can see all the logs channeled into one place. Pretty cool, and it has like a load balancer that the world can access your services. It comes with an internal Docker registry as well. Of course, it's not working. So I can't show you the demo. It's not working. You got to trust me. But basically, this command, Dace build create, I'm just building it and deploying it. So it's literally one command to deploy your stuff to your cluster, deploy your service. If you want to scale it, if you see it to get a lot of traffic, you just do scale CMD equals number, and that's it. It scales it on more instances. So yeah, go to Dace's website and check it out. It's pretty cool. This one is very cool too, Convox. So Convox is very similar to Dace, but it's very, very simple. It literally will take you like a minute to install. Just like 2 lines in the command that install the command line for you, called Convox. So actually, I'm using it right now. Let me see. It comes with a nice web interface. So you can see they have only, it's called a rack. So I only have a dev rack, but you can have dev, stage, production, whatever you want. And if I click on it, you can see all my services that are running. Even this talk is running on Convox right now, so Docker culture. And obviously, I have a DNS entry to point to point to whatever host name I'm getting from Convox. So they're all using Amazon. So if you guys are familiar with Amazon, they have ELBs. Actually, I have write a blog post about this stuff. So I go to my blog. So I was so impressed with this when I discovered this stuff. It was built by a few Heroku engineers that left Heroku, and now they're building this. And when you run the Convox install, right, after you install the CLI, which is 2 lines, you need to run Convox install. It will set up everything for you. So you can see that it will set up 3 availability zones with a subnet in each of them. And then you have, whenever you run the Convox command line, it will hit this HTTP endpoint. And you can start doing stuff. And it's using all Amazon well-known components, DynamoDB for storing all the build, the different builds that you have, the unique build IDs. S3, that's where they're storing the images. So you don't need to use them in the Docker Hub. It's all in S3, which is Amazon key value database. So all the images are stored in a pretty efficient way. So every time you every time I push this specific repo, the Docker, this presentation, when I push to master, notice that I have here in the grid, I have this connection, right? The Docker culture. It's a few clicks, and now it pushes it to my Convox cluster. That's all I need to do, and it's also doing it in zero downtime. So it knows to like only run your new instances after it shut down gracefully the previous instances. And every time you run Convox, let's see the command, I can't remember, right? So basically what Convox creates for you is an ELB for each of your apps. And it decides where to put the circles are containers, and it decides for you. And you can also scale it for, the default is 1 instance, but if you do use the scale count, it can put it on multiple instances for you. So if I show you here, Convox, it's too small. Oops. So I'll make it, where's my other terminal here? Let's get out of the container. DRM is a little alias to stop and remove all the containers that are running, because if you forget, it's going to mess up your stuff. So I'd rather destroy everything. Convox, right? That's a command line. Apps will show you the same stuff that you saw on the UI, but you can see it here. And I can see, let's see the logs from specific apps. I can do Convox logs or info. Let's do info of my Docker-culture, which is this Nginx website that's running this specific talk, right? And you can see the endpoints. I can go and, so in my DNS, I had to point Docker-culture to this. So that's that's the ELB that I get from Convox, right? And I can do scaling if I want. I can remember the command, but that's the idea. It's pretty powerful. So let's go back quickly. Wow, graph databases. Hopefully, how much time do I have? 1 minute? 8. Okay. Okay. So there are 3 graph databases out there that are actually useful. And we did a lot of research, me and the team that I work with. Titan and Neo4j are both using the JVM in Java. Kali is in Go. The most dominant one is Neo4j, and that's the one that actually we use. Titan is a little tough to use, but there's some interesting properties in Titan that you should look into. Why graphs? Why graph databases? So the way I see it is that it's very hard to map the world into the data, and the relational databases are not doing a good job of this stuff. And also the cost of change. So let's say you build an app and you have like some patient and you have a study that you want to connect patients. So you build 2 tables. You connect them with a primary and foreign keys. And then you realize, oh, I need actually to have the same patient can be in multiple studies. And things start to grow, and then you need to start refactoring and create like a many-to-many table, right? Another table, and you need to move the keys from one place to another place and change it from foreign keys to primary keys. It's pretty messy. Like, it's even hard to like describe this stuff. If you put it on a whiteboard or if you look at a graph diagram or a diagram of a relational database, it's hard to understand what's going on. It's hard to communicate with people who are not familiar with this stuff. Talk to your product guy about or your product team, it's going to be hard. And I think in graphs, it's actually easy. It's very whiteboard friendly. You just create the nodes that you want. So you have a patient here, that's a node, and you have a study here, and you have some edge in between them. And the edge, you can name it. And in some databases, you can actually have key values both on the edge and on the nodes. So you can have the edge and call it participated, or can be from, or whatever. You can have multiple edges, right? So that's kind of like how you map the world. So it's hard to show it without an example. So I'm just going to show an example that might be relevant to you guys. That's just nice metrics that I found. I can't remember where. It's called the TTFHW, time to first hello world. And like, if you look at this stuff, Kayla is about 2 minutes. Titan, a weekend. Neo4j, 20 minutes. I don't know. That took mine, but it depends. It's a metric that I really like to use when I'm evaluating tools. So you guys are familiar with this guy? Yeah. So that's the example that I want to give you about graph databases. So I went to Twitter, and I was kind of amazed. Like, what the hell? So people are moving to Canada from the US because of this guy. And some people in Canada are pissed because he noticed that somebody is voting for Justin just because of how he looks. And some people are leaving Canada. So there's some interesting dynamic here. People are leaving Canada and coming to Canada. So I wanted to map this stuff. And then I found an interesting thing that people said he doesn't like the Blue Jays, and he bans puppies. So I want to show you a demo of Neo4j. Localhost. So Neo is already running, or maybe not. Neo. Oh. I spent so much time on this stuff. Wow, hours sometimes. Can't remember to change my host file. I had to restart my machine like 20 times because of the Wi-Fi issue. Neo came up with a new version actually a week ago. Neo4j start. Crossing fingers. So yeah, I tried to map the stuff that you saw on Twitter into like Neo4j. Okay, it comes with a beautiful interface. Uh-oh. Whew. Okay, and I think I have here, I have nothing here. Okay, I need to find a script. Where's my script? Neo. Okay, so in this script, it's called Cypher, the language that Neo4j are using. And it's kind of like ASCII art. It's actually pretty interesting. I just created my entire graph, and I'm going to run match n, which will show me kind of like select all basically on the entire graph. All right, so let me I can take people, let's say Justin here, and click on the person, make it bigger, right? And I can see that Justin is in love with, Sarah is in love with Justin. Christy is in love with Justin. Christy is moving to Canada. And she lives in the US right now. And where is the guy that is pissed? Tyler. Tyler lives in Canada. He moving to the US because he's pissed with Sarah. And you can see that Justin is banning puppies. And he hates the Blue Jays. So I just mapped the world, and it was pretty cool. And it's fairly easy to create and add more edges and nodes. So let's try to see if my script is accurate here. Or I can also show you how to run queries. I want to see who is in love with Justin, right? So let's see. In love with. So notice that the syntax is like, this is a node, the parentheses. So match any node, and this is the relationship, whatever you call this guy, in love with the relationship. And then here I can say, connect to another node that have name Justin. Anybody that has this node to Justin. And then return it, return P. So I see Chrissy and Sarah, right? And let's do something more complex. Who is in love with Justin, live in the US, and is moving to somewhere else? All right, I got Chrissy, right? She's moving to Canada, and she's in love with Justin. And let's try to add a node. I'm adding somebody that Justin decided to ban somebody because of Twitter. So I'm just saying, hey, match Justin. After you match it, after you find the node, then add another edge called blocks to another person called Josh, right? Run this stuff, and I got the connection. And if I run the entire graph again, boom, right? So I can see here a new edge between Justin and Josh, which is he's blocking it. So yeah, that's kind of like, I don't know, a quick introduction to graph databases. I don't have time to show you Kaylee. It's pretty awesome, trust me. Do I have time, or I'm done? I'm done. So that's the last thing. I think the evolution of containers might be just a function. I'm not sure if it's going to catch up on Fire, but it might. So you can, in the future, just grab a function, put it on, right now, at AWS Lambda. But there's other competing approaches. This is one of them. Thank you.